Okay, now am I audible to all of you? Please check the sound. Am I audible to all of you? Please tell me. Always remember one thing. If someone asks you about the, please recheck again. Am I audible to all of you? Please check the sound. I was telling you I'm going to start with the chapter Earth today. So I was just going to describe you about the origin of Earth. Deepika Goyal, Jyoti Kumari, then we have Kanish Dubey. Am I audible to all of you right now? Please check the sound. Please inform me. Okay, so I was talking about the origin of Earth. If someone asks you, when did the origin of Earth took place? So what will be the answer? You will simply say, the origin of the Earth took place around 4.5 billion years ago. And remember one thing, it is believed that previously all the particles in the universe was in the form of nebula. And what was nebula? It was cluster of dust and gases. It is believed that when this slow moving nebula, which was a cluster of dust and gases, when it got compressed and when it exploded, then it resulted into the formation of the smaller planets. So we can simply say the supernova explosion and Big Bang explosion is considered to be the main theory before the Earth's origin. And remember one thing, the widely accepted theory around the globe is the Big Bang. And remember one thing, Big Bang theory was proposed by a Belgian priest, Abbe George Lemaitre. And it is believed that when our Earth was created, so if you look at the Earth structure, you will simply come to know that initially our Earth was into two important parts. One part was called as Pangea. This is the solid rock part of our Earth. That is Pangea. And this Pangea was found to be floating. It was found to be floating on a fluid called Panthalasia. So Panthalasia was a fluid. It was in the liquid and gaseous form. So we can simply say that when the origin of Earth took place, our Earth was basically present. Our Earth was basically present into two important parts. The solid rock part of our Earth was called as Pangea, and the fluid part of our Earth was called as the Panthalasia. And this fluid basically mean two important things, that is the liquid part as well as the gaseous part. And remember one thing, it is believed that due to the change in temperature, with the passes of time, and due to the change in density, this solid rock part of our Earth, Pangaea, began to disintegrate. It began to drift, and because of the drifting of the Pangaea due to change in temperature and density, it was bifurcated into two important components, that is called Angara and Gondwana landmass. So we can simply say that due to change in temperature and density of our Earth's rock particles, and fluid components, it began to drift or disintegrate. Because of this drifting, Pangaea got broken in two parts. It was broken in two parts. Now simply look at this particular image. This is Pangaea. Now due to the drifting of Pangaea, the one portion that went to the northern part, this was called as Angara landmass, and the another part that disintegrated towards the south came to be known as the Gondwana landmass. So to the north of the Angara land, this is also called as Angara, or we call it Laurasia. This is also called as Laurasia. Am I clear to you? So this Pangaea disintegrated in two different directions, and it resulted into the formation of two important land masses, Angara landmass as well as the Gondwana landmass. Now, this Angara and Gondwana, this further disintegrated. This Angara and Gondwana further disintegrated. So this is Angara landmass. This is the Gondwana landmass. This Angara disintegrated into three parts. It resulted into the formation of North American plate. Then we have Eurasian plate, and then we have Indo-Australian plate. And this Gondwana landmass further disintegrated into South American plate, African plate, then you will say Antarctican plate, and finally we have the Pacific plate. So these are considered to be the 7 major tectonic plates of our Earth, which has resulted into the formation of 7 major continents, as well as it has resulted into the formation of 7 major continents, as well as the formation of different types of oceans and the sea. So if the question comes to you, on our Earth, how many major tectonic plates are situated, so you will say we have altogether 7 major tectonic plates. The 3 major tectonic plates are formed by due to the disintegration of Angara landmass, and 4 major tectonic plates have been created or have been formed due to the disintegration of Gondwana landmass. The Angara landmass disintegrated to form North American, Eurasian, and Indo-Australian plate, and the Gondwana landmass disintegrated to form the South American, African, Antarctican, as well as the Pacific plate. Am I clear to you all? And this Angara is also called as the which one? You will say Laurasian plate. This is also called as Laurasian plate. We call it Laurasian plate. Am I clear to you all? Please do reply to me very quickly. All of you. Do respond to me. Do reply to me as quickly as possible. All of you, please go ahead. If you have any doubt, any problem, any query, please do respond to me. Are you understanding all the things properly? Do you have any query, any doubt? We can simply sort it out. And if no, I will proceed. Please tell me. So we can simply summarize here that there are 7 major tectonic plates. There are 7 major tectonic plates. We can say it, we can summarize it as North American tectonic plate. Then we can write it Eurasian tectonic plate. We can write Indo-Australian tectonic plate. Then we have South American tectonic plate. Then we have African tectonic plate. You will get it memorized if I'm writing it time and again. Antarctican tectonic plate. And then we have Pacific tectonic plate. Am I clear to you all? So simply remember this. This is how the tectonic plates came into existence. Now, simply remember one thing, कि our Earth, our planet Earth is composed of different layers. It is composed of different layers. Normally, we can subscribe it into the crust, which is supposed to be the outermost solid layer of our Earth. Then we have mantle, middle layer of our Earth. Then we have core, innermost layer of our Earth. This is the core one. And core is supposed to be the hottest layer and dense layer. Now please look at the diagram. If you look into the diagram, you will come to realize that this is the outermost layer of our Earth, which we call as crust, and this is divided into 2 parts. continental crust and oceanic crust. When you will move 80 to 100 kilometer beneath the crust or below the crust, you will find a very weak layer that is called as asthenosphere. And on this asthenosphere layer, we have 7 major tectonic plates floating. This is the asthenosphere on which, and this asthenosphere is between crust as well as the mantle. So below the asthenosphere we have which layer? Mantle layer. This is divided into two parts: outer mantle and inner mantle. And do remember one thing, the innermost layer of the earth is the which one? You will say core. And this is divided into outer core and inner core. Do remember that. One thing is very clear, the thickness of the continental crust is about 30 kilometers. The thickness of oceanic crust is 5 kilometers. Crust to mantle, this is 2900 kilometers. Mantle to core, 3500 kilometers. And when you add both these lengths, it will be 6400. So radius of the earth will be 6400. But remember one thing, as you move from crust to core, as we proceed from crust to core, simply remember one thing, while moving from crust to core, remember one thing, while moving from crust to core, temperature increases, density increases, and pressure also increases. So we have the increase in temperature, density, and pressure. So we can simply say the inner core is most dense. This is most dense. It is having the highest pressure and it is also having the highest temperature. Because of the presence of extreme temperature, extreme pressure, and extreme density, this innermost layer of our Earth's surface, earth layer, that is inner core, this is in the solid form. This is the most important thing that you need to understand. If the question comes, if the question comes, the inner core is present in which of the following state? Is it into the solid form? Is it in the liquid form, or is it into the gaseous state? You will simply say, since the inner core is witnessing highest temperature, highest pressure, and highest density. So because of the presence of highest temperature, highest density, and highest pressure, this is supposed to be the most dense layer and it is in the solid form. The outer will be into the which form? This will be in the fluid form. This will be in the fluid form. The outer and inner mantle, it will be into the solid state. This will be solid state. The asthenosphere, this will be into the which one? You can say this is solid and smooth. And crust is, obviously this is the solid one. Continental and oceanic. Do you have any problem in understanding this? Please respond to me. All of you, if you have any doubt, any query till this point, we can discuss. And this asthenosphere, this is 80 to 100 kilometer. You will get the general science videos as well. No, we have the general science session going on. It's at 9 a.m. You can watch it live at 9 a.m. Simply remember one thing. Temperature at inner core is approximately 10 million degrees Celsius. This is the temperature at the which one you can say inner core. The temperature is 10 million degrees Celsius. Also remember one thing. If the question comes, what is lithosphere? What is lithosphere? You will simply say lithosphere is crust including outer mantle of our earth. So remember one thing, crust to outer mantle. This will be called as lithosphere. And remember one thing, thickness of lithosphere vary from 20 to 200 kilometers. This is the thickness of the which one you will say lithosphere. And always remember one thing, on our earth's crust, the elements present according to weight are. So according to weight, if the question comes, can you arrange the elements on our earth crust? Simply remember, this is OCl, Irka, Nakmag. So O is oxygen, Si is silicon, Al is aluminium, Ir is, it is just to remember the trick, iron, though it is Fe. Then comes the calcium, then comes the sodium, then comes the potassium, and then comes the magnesium. OCl, Irka, Nakmag. You have to remember this code just in order to remember all those elements which are present on our earth crust according to the decreasing order of their weight. So the heaviest element which is present on our earth crust according to the weight is which one you can say oxygen. So I have given you the code OCl, Irka, Nakmag. OCl, Irka, Nakmag. Please do remember this. OCl, Irka, Nakmag. This is the code to remember all these elements according to their weight which is present on our earth crust. Am I clear to you all? Can you please respond to me? OCl, Irka, Nakmag. Nakmag. OCl, Irka, Nakmag. You don't have to remember the weight composition of each element. If you are able to memorize this code, if you are able to memorize this particular lineage, you will be able to understand all the elements which are present on our earth crust. So this is OCl, Irka, Nakmag. This is as simple as that. Can you please reply, all of you? Now remember one thing. If you talk about crust, this is made up of which one? You can say Cr. What is Cr? Silica and aluminium. If you talk about mantle, this is composed of SEMA, silica and magnesia. And if you talk about core, this is knife, that is nickel and iron. This is the composition of crust. This is the metallic composition of mantle, and this is the metallic composition of which one? You can say core. We have started the physical geography. This is the physical geography. Am I clear to all of you? Please tell me. Remember one thing. You all know that on crust we have two division. That is continental crust and oceanic crust. Then after crust comes the mantle, and this is distributed into two layers, outer mantle and inner mantle. Then mantle, then comes the core, which is outer core and inner core. Now in order to understand this, you have to simply remember one thing. There is a term called discontinuity. Have you heard of discontinuity? Discontinuity. Simply remember one thing. This is a thin layer which separates two different layers of our earth. Two different layers of our earth. Now please remember one thing. Please remember one thing. The continental crust and oceanic crust, they are separated with each other by Conard discontinuity. Conard discontinuity. The crust and mantle, they are separated by Mohorovic discontinuity. Outer and inner core, they are separated by Repeti discontinuity. Then comes the mantle and core. Mantle and core, they are separated by Gutenberg discontinuity. And finally we have the outer and inner core. This is by Lehman discontinuity. Am I clear to you all? So these are the discontinuities of our earth which separates one layer from the other layer. So this is all about the basic information of our earth. So guys, please do subscribe our channel Online Benches by Exampur for SSC and railway exams in English medium, and do share this channel with all your friends. And also please note down the timetable for the YT session that we bring to you in the English medium. 7 AM current affairs. It's by me, Chandan Raushan. 9 a.m. General Science, Dr. Jubair Ehsani sir. 10:30 a.m. Vocabulary, Nitin Mishra sir. 12 p.m. English, Nitin Mishra sir. 2 p.m. GKGS, that is myself, Chandan Raushan. 5 p.m. Mathematics, Deependra sir. 6 p.m. Reasoning, Sonal ma'am, and 7 p.m. GKGS by Prabal sir. So please press the bell icon and please do share the session and subscribe the channel. Thank you so much, guys. See you tomorrow. Till then, have a great evening ahead. Thank you so much and enjoy your afternoon. Bye bye and take care.